Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Chemistry Revision Lesson series. Today we'll run through the reactivity of metals. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. Let's firstly talk about metal oxides. Metal oxides are produced when metals react with oxygen. We have learnt about redox reactions in the context of gaining or losing electrons, but redox is also in terms of the addition and removal of oxygen from a substance. So let's see what redox in terms of oxygen entails. Oxidation reaction. Oxygen is added to an element or a compound. The element or compound that receives the oxygen has therefore been oxidized. For example, magnesium plus O2 gives you magnesium oxide. As you can see over here, magnesium has gained oxygen, therefore it has been oxidized. Reduction reaction. Oxygen is removed from an element or compound. The element or compound that loses the oxygen has therefore been reduced. For example, zinc oxide plus carbon gives you zinc plus carbon monoxide. As you can see, zinc has lost oxygen, therefore it has been reduced. Speaking of adding and removing oxygen from elements, let's talk about oxidizing and reducing agents. An oxidizing agent adds oxygen to another substance, and a reducing agent removes oxygen from another substance. For example, you can see that we've got copper oxide plus hydrogen, which gives you copper plus water. The copper oxide acts as the oxidizing agent as it adds oxygen to another substance, and the hydrogen acts as the reducing agent as it removes oxygen from another substance. Now, we have gone through the reactivity series and the order of metals it comprises in the video entitled Displacement Reactions and Redox in Terms of Electrons. Now, let's look at what we can learn from the reactivity series and its scientific background. When metals react with other substances, metal atoms lose electrons to form positive ions. The reactivity of a metal is related to its tendency to form positive ions. So essentially, reactivity is linked to how easily an atom can lose its electrons. Reactivity series lists metals in order of their reactivity. The higher up the reactivity series a metal is, the more easily it reacts and therefore the more reactive it is. Carbon and hydrogen are included in the reactivity series despite being non-metals, which is because they are useful in extracting metals from their oxides by reduction. A more reactive metal can displace a less reactive metal from a compound. This is the reactivity series in order. Make an effort to memorize the order using the mnemonic as it's important in case it's required for a question. This information is not provided to you in exams like the periodic table. Now, we have mentioned how hydrogen and carbon can be used to extract metals, but how does that actually occur? Unreactive metals such as gold are found in the earth as the metal itself. However, most metals are often chemically combined with other substances, forming ores. Chemical extraction is required to extract the metal from these compounds. The ore is often an oxide in many cases, therefore extraction of these metals is a reduction process since oxygen is removed. Metals less reactive than carbon can be extracted from their compounds by heating with carbon, which reduces them. The carbon removes the oxygen from the metal oxide. Carbon dioxide is formed along with a metal element. Metals higher than carbon have to be extracted by other methods such as electrolysis. A general equation of this process would be metal oxide plus carbon gives you metal plus carbon dioxide. Now let's put our knowledge to the test by answering the following questions. The first question is this multiple choice question. Have a go at this independently and return back to the video once you are done to check your answers and add any corrections. Which of these metals is the most reactive? A. Iron, B. Potassium, C. Aluminium, or D. Silver? The answer is B. Potassium. From all of these metals over here, potassium is the highest up in the reactivity series. Let's try another question. As you can see, this question is testing your knowledge of oxidizing and reducing agents and redox in general in terms of oxygen gain or loss. Have a go at this and return back to the video to add your corrections and to award yourself marks accordingly. For this reaction, give the formula for Fe3O4 plus 4H2, which gives you 3Fe plus 4H2O. Provide the oxidizing agent, the reducing agent, which substance has been oxidized, and which substance has been reduced. Award yourselves 1 mark for each of the following, and add any corrections if you have not added it already. The oxidizing agent is Fe3O4. The reducing agent is 4H2. The substance which has been oxidized is 4H2O as it's gained oxygen, and the substance which has been reduced is 3Fe as it has lost oxygen. Let's now try this 3-mark question. It is an explain question, so refer to scientific content and remember to use the word because. The question is to explain why only metals below carbon can be extracted through a reduction process with carbon. Once again, award yourself 1 mark for each of the sentences that you have written correctly. If you have missed anything out, add it to your corrections. Carbon is higher up in the reactivity series than those metals. Therefore, it is more reactive than them. Therefore, it can remove the oxygen from the metal oxide. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2 and 3, along with specially formulated 11+ GCSE and A-level lessons. Further information can be accessed on our website at tessonlineschool.com. And if you would like further resources, advice and feedback, please contact us on the following numbers. Thank you.